Okay, well, welcome everybody to Solar Noon Tuesday. I'm Jay Warmke with solarpvtraining.com. And if you're new to these sessions, essentially what we do here is it's kind of a weekly meeting where we try and get together, talk about all things solar. We have a lot of folks online as this is being recorded, and hopefully they'll have questions or jump in or give answers if I don't have the answer. So that's part of the plan here. And then as we're moving forward, there are sort of three sections here. I'll do a brief recap of the news and of what's happening in the world of solar. And then there are also webinars and events that are coming up that I try and highlight. And then we'll jump into a deeper dive of a subject that's of interest. And this week, what we're going to be talking about is Enphase has come out with a new product line of their Enphase microinverter system. And since that is really in the residential world in the US, the number one installed product line that's out there, we just thought, okay, well, let's take a look at it and see what's different. So as I mentioned, let's jump in. This is the week of August 10th, 2025. And here's the news that's been happening over the last 7 days or so. The Environmental Protection Agency last Thursday terminated a $7 billion grant program that was intended to help pay for residential solar projects for more than about 900,000 lower income residential U.S. households. The funding was part of the Biden era's Solar for All program. And I think they sort of anticipated that this was going to be a thing. If Trump won the election, he'd try and do away with it. So they awarded it to 60 different recipients for redistribution out there on these individual projects. These included states, tribal governance bodies, regions, nonprofit organizations. And they were then to reallocate this money for investments in rooftop and community solar. Well, so far, since the money was originally earmarked, only $53 million of the original $7 billion has already been spent, according to a tally by the research firm Atlas Public Policy. And a number of the policy insiders contend that the EPA has no legal authority to terminate grants that were already appropriated by Congress. So clearly, this issue, like so many, is going to be headed to the courts. President Trump signed a new executive order last week imposing steep countrywide tariffs on India. The U.S. government will impose an additional 25% tariff on imports from India effective August 27th. These tariffs are on top of an existing 25% tariff that was imposed under the April 2nd executive order. Now, it's anticipated this is going to impact the solar industry, to a marked extent, because approximately 88% of all of the panels installed in the U.S. are imported, and there had been incentives in the Inflation Reduction Act designed to encourage domestic manufacturing of solar panels and solar cells, but those have been eliminated under the new budget reconciliation by the Trump administration. But India has become an increasingly important partner in sourcing U.S. panels, serving as a less expensive alternative to panels that were originally imported from China. But when tariffs were imposed on China and restrictions on import from China, then those manufacturing facilities moved to Malaysia, Cambodia, Vietnam, Thailand. Then it was ruled that that was simply China trying to avoid tariff by moving to another country, which was kind of everybody going, yeah, duh. But anyway, they then decided they were going to impose tariffs on panels from those nations. And those tariffs are amazingly steep. In fact, panels imported from Cambodia, the tariffs range from 650 to 3,500%. From Malaysia, the tariffs go from 14 to 250%. The Thai tariffs range from 375 to 972%, and the Vietnamese tariffs from 120 to 813%. And now we're seeing 50% tariffs on those from India, which, as you can see from this diagram, has become one of the leading suppliers of panels to the US. D3 Energy has officially launched construction of a 6 megawatt floating solar system in the village of Monroeville, which is set to become the largest floating solar installation in Ohio and one of the biggest in the country. It was spearheaded by the village of Monroeville and developed in partnership with D3 Energy. And the system is going to feed the village's distribution grid, delivering power to the homes and businesses within that community. There is a long-term power purchase agreement. It's part of this from the project's owner. By using the village's existing reservoir, they anticipate they'll be able to preserve 30 acres of land that would have otherwise been required for an array this size using a traditional ground-mounted system. And this process called photovoltaics, in addition to conserving land, it does offer some environmental benefits. It does keep the panels cooler by being over the water. It minimizes evaporation from that water body, and it does improve the water quality by avoiding the buildup of algae and things like that in that facility or in that lake. Sodium-ion battery storage startup Peak Energy has announced its first shipment of its storage system that'll be used in a shared pilot between 9 utilities and independent power producers later this summer. The Colorado-based company touts its battery as the first ever fully passive megawatt-hour scale battery storage system and the largest sodium ion phosphate pyrophosphate, an NFPP battery system in the world, and the first grid-tied system grid-tied to the U.S. grid. A passive storage system is basically it requires no active cooling processes such as fans, pumps, or other cooling parts or moving parts that prevent lithium-ion batteries from overheating. Peak Energy claims that its 3.5 megawatt-hour battery system, or BESS, eliminates about 85% of all the root causes of these BESS system failures. According to Peak, their sodium-ion system allows batteries to operate in a wide range of temperatures without requiring these cooling systems that are typically required to prevent overheating in lithium-ion systems. Performance tests by Peak indicate that sodium-ion systems will reduce the auxiliary power, or the power that's required for these cooling systems, reduce it by up to 90%, saving about $1 million annually per gigawatt hour installed compared to lithium iron phosphate systems, and that they'll last longer, cutting battery degradation by about 33% over a 20-year period. So new technology there. And that's all the news that I came up with in the last week. Does anybody have anything they'd like to add to that that came across your desk as we're moving forward? Give you just a second. While you're contemplating, I'll give you some of the announcements here that are coming, events that are happening over the next month or so. Tomorrow, August 13th, there's a trade and finance webinar at 1 p.m. All of these times are Eastern time. I was going to say Eastern Standard Time. I think we're on Standard Time. It's hard to know. Does anyone really know what time it is? Okay, then there's Energy Transitions, August 14th at noon from S&P Global. Solar Power World has essentially a total quality solar event on the 14th at 2 p.m. These are all free webinars. Solar Builder is going to have one on project management, same time, 14th at 2 p.m. Then there are also one on the 19th about ancillary services, so things other than just the installing of solar that you can build into your business services. Then Drive Clean Rural USA is putting on a webinar on the 21st at 3 p.m. And 26th, there's one on advanced conductors. So that's from Utility Drive. Then another one on August 26th, IEC 62446. And that's in case you're interested in that particular standard. One on schools, solar for schools. And that's put on by Solar United Neighbors. On the 28th, commercial and industrial projects, and they're talking about designing them around the integrator the inverter. I think most projects sort of start with the inverter, however you're going to do that, at least in my mind, they do. And connectivity connectors, talking about the connector issues on September 4th. And then, of course, our blatant self-serving advertisement here on the solarpvtraining.com. We have in-person classes and online classes that we offer around the Midwest mostly, and online. Okay, so those are the events. So once again, I'll ask, does anybody have anything before we get into our topic du jour? Anything anybody wants to bring up for the good of the cause? Okay. All right. So let's jump into the Enphase. Enphase has a new product line out there. And as I mentioned, Enphase is the number one install for residential here in the US. So it just felt like we should go ahead and take a minute and look at what's different with this one. One of my criticisms of Enphase, and I like their products for sure. That's I'm being nitpicky here, but when they do come out with a product line, it's never backwardly compatible, which I always find a little bit annoying. Now, in looking at all of their videos and seeing their explanations, there's good reason for that, is because they're trying to address issues that have come up in their past products. And in order to address those issues, they cannot be backwardly compatible. For example, when they went from the second generation of their product to the third generation, one of the big issues had to do with communications. And they had been using a wireless communication platform, and that was causing problems. It was causing problems of crosstalk with other systems that might be located nearby, or getting involved or losing signal, or lots of different problems. So they went with a hardwired communication system. Well, when we talk about communication system, all the different components have to talk to each other. So the smart switch has to talk to the batteries, and the batteries have to talk to the switch needs to talk to the combiner box, and things like that. So they use hardware. Well, then you need a different product. So they're no longer backwardly compatible. Well, we have the same issues here going to the fourth generation, and I'll highlight what those are. But before I get into that, these sessions have been granted half-hour or 30-minute CEU with ETA, with the Electronic Technicians Association International. So if you are certified with ETA in solar specifically, but perhaps in their electronics, then you could use this and get some credit for your renewals, things like that. Okay. Oh, and I've got so many caveats before I jump in, but somebody had sent me this, and I just thought it was worth noting before we got started on the Enphase thing, because it's a different product. And I find it interesting because one of the things I've been ranting on, I just spoke to an architects group down in Atlanta, and I submitted an article to ASIS magazine, and it's the fact that, of course, these cutbacks by Trump with incentives for solar, I'm not all that hyped about incentives. I think the industry should and could and can stand on its own without incentives. I just wish they do the same thing for the fossil fuel industry, cut off those incentives as well. But the big issue is going to be, is the nation ready for what is about to hit it, with this hockey stick demand curve that's coming on from AI, data centers, electric vehicles, electrification of heat, global warming, when we add those. And I don't want to relitigate all of that, but we are going to see this increased demand. And then they're cutting off the one source of new energy that has been proven successful over the last 5 years, with no alternative out there. There really is none. So the best case scenario is they're just going to make solar and wind 30% more expensive when they cut off the 30% incentive. Okay, well, that's all right. But then on top of that, you start seeing all these other price sensors. So, okay, that said, my thinking is when people start seeing their electric bills doubling, tripling, they're going to try and take action. Those who can afford it are going to want people to install solar on their homes, but there are not that many solar installers out there to meet that kind of demand that comes all of a sudden. So they're starting to come up with products that are going to work, that don't require any installation. Now, that's always going to be a wee bit of a problem, but this is one of them. And I just found it interesting, their approach. Basically, what you're dealing with is you've got these components here, and it's a 1640 watt DC, with the array. And then realistically, it's just 900 watts coming out of that microinverter. So it hooks into a microinverter, but it's got a communication and it's also got a smart switch. So, and it's got a battery. So that little 1800 watt, I think, is the smart switch thing. And then the battery, the 3840 watt hour. Anyway, this is something when you go to install it, you just plug it into the wall. There is no installation. It's a 120 volt system that just plugs into a regular outlet. So this is the kind of solution that I'm thinking people are going to be looking at. It's a small system. It does have an auto disconnect there. So in case the grid goes down, it's going to shut off, which is one of the things that if you jury rig your own little system, that could be problematic. Well, that's nice that they built that thing in. But I just think there's going to be this huge demand for these little, here, set up a few panels and now you've got some power. We're going to offset some of that electricity. This seems pretty pricey. I mean, if I back up here, you can look, it's 3,900 bucks for essentially 900 watt output. I mean, come on, that's expensive. But, that's the idea is there. I think the idea is there, and we're going to see, I think, more of this kind of thing coming out. So I just thought that was interesting. Okay, that said, now we're actually on to the Enphase. So Enphase, we've got the third generation. Just to remind you what was part, if you've installed one of these Enphase systems, and all the different components there. There's the combiner box. There's the microinverter, of course. Now, the microinverter for this fourth generation hasn't changed. They're still anticipating that they're going to be using the IQ8 pluses. So, but certainly the combiner box changed. But basically, the combiner box with the third generation was a hardwired communication system. It has the communication system inside of that box. Typically, it has some CTs. So there's in the bottom left corner there's a CT that you feed the black wire from the lines coming in from the array so that you can measure production. Then there's connection points there for CTs. And this was always a little bit of a problem. You got this long wire with these cumbersome CTs, and you had to attach those to the lines coming in from the utility in your service panel. And then you had to somehow, in a conduit, run that back to the combiner box. So that was a little bit annoying if you wanted to measure. And what you're measuring there with the CTs that connect to the service, to line 1, line 2 coming from the utility meter, is power that's flowing out to the grid from your system and power that's flowing back in. So you can measure all of these things. And so that's just a closer up there. You can see where the connection ports for those CTs, those blue and white wires connect in, all there on the right. And that little breaker that's in there at the moment is only for to power all of the communication. So it's a little breaker. It comes pre-installed. And then there are 4 slots there. You can just put in 4 slots for 4 branch circuits coming from your array. And then at the bottom, those lugs at the bottom of those bus bars, those just go off and they connect in through the AC disconnect to your smart switch, to the system controller. I should say, there's the bus bars. There's the communication system. I forgot I had arrows. There's the CT. All right, so then we get into the smart switch. And the smart switch, in this case, in this third generation, is sort of the brains of the operation. And it's a pretty big piece of equipment, pretty heavy. That silver thing in the middle up there is it's a neutral, generating a neutral. I guess it's a transformer. I assume it is. It's heavy enough. Then you've got some breakers in there where you can hook in. You can hook in from your grid. You can hook in from your array, from your combiner box. There are ports where you could hook in your battery system, which are highlighted there. Also, you could put in a generator. So think of this as a traffic cop. It's essentially everything's getting hooked in here. You could go directly if you're doing a whole house backup. You can go directly from the meter and go in here and land your main in here. Or if you're doing a partial backup where you've got a backup load panel or a critical load panel, you could then connect from your main panel in here and then from here to your critical load panel. So you've got those options. And this became sort of the brains of the operation. Now we're still reviewing third generation. Another thing that they had here is a load controller. So you could then anticipate which loads you wanted to back up in what priority. So this load controller, you would put in, I think then Smart Switch had up to 4 double pole breaker locations. So in theory, 8 120 loads or 4 240 loads that could then be prioritized from that Smart Switch. And the idea there is, let's say that you only have a small battery or you don't have any battery at all, and you're just working off sunlight backup from your inverters, because those IQ8s will operate when the sun is shining, and there is no grid. So they call it self-grid forming microinverters. So they'll work when the sun is shining. So they're providing power as long as you've got that smart switch, so you can disconnect from the grid and you're not backfeeding. But you may not have enough power to run all the backup loads, so you can prioritize them and just go with what you can service. And it will automatically detect and it'll just turn off in sequence the ones. So you got to think about your empowering loads to be backed up. The new system takes a different approach. They take an approach of, they assume you want to back up everything, but you can turn off certain large loads. So, and you can prioritize the turning off. So if you had, let's say, a whole house backup, but you want to turn off your car charger, you want to turn off your hot tub, you want to turn off your air conditioner unit or whatever, which kind of makes a little more sense, than as opposed to how do I enable these in a certain order. At least they're anticipating you're going to put in a bigger battery for sure. Okay, so we throw in these prices because I just always like to say, okay, well, you're talking about these things. What is roughly the price? So looking it up yesterday or so, the microinverters, you can get those for about $173. I'm sure you can get them cheaper if you search around. Combiner box was just under $800. That smart switch was pricey, $2,100. And if you get one that incorporates a generator connection, you add another $800. So you're going to pay almost $3,000 for one of those system controller 3s that will accept a generator. And then the load controller unit was $400 and some dollars. And then you could buy a 5P IQ 5P battery, which is the battery that goes with this system, basically, because remember, these things are now wired communication. So you couldn't use the 3T or the 10T, which was second generation stuff, because that communicated wirelessly. So you had to use the 5Ps. So $4,000. Okay. Any questions so far when I'm talking about third generation? Because I don't want to get ahead of our skis here.
Yeah,
Anybody? Yeah, go ahead, Siggy.
the load controller, is that mandated to operate to commission, or can that be skipped?
It can be skipped. It can be skipped. The only reason I see for using it, and we put one in here at our office because we didn't have a battery at first. So we were dealing just sunlight backup. And because sunlight is very intermittent and you don't know what you're getting, we just prioritize the loads. But now that we've got the battery, there's kind of no reason for it. It's still sitting there, but I don't anticipate it's ever going to be used unless we just drain down the battery to a low capacity. So, but you can skip that for sure. All right. Any other questions?
Jay, that previous photo that you had of I think it was the load controller, did that have anything coming into it there? It is.
Yeah. This is kind of bare. Yeah, this is an empty one. Of course, these are just relay switches or something. So you bring your wires in, you'd land your hots and neutrals in there, and then they would continue on to your breaker box. So this is just a way of turning on and off those switches. So yeah, this is a non-wired load controller. So you're right. It's mostly there just for cable management. So does that make sense? Okay. Any other questions before I jump forward? All right. Well, here's fourth generation. So this is the fourth generation. Now, if you look, it's quite a bit different. Look at third generation here. Lots of stuff. Now, of course, they threw two batteries there just to make it look like, it's a lot more stuff. But here on the wall, when they're just demonstrating, there are actually two 5Ps here. So those two batteries, 10 kilowatt hours. Then there's, as we go from right to left, we've got the combiner box. Then we've got the smart switch, and it has a rapid shutdown initiator. So that's basically a way of turning off the batteries. You need to have that, and it's got to be out there near the meter. And then, of course, there's the meter. And then underneath that, I assume that's the load controller. So that's the third generation. We jump up here to the fourth generation, and going right to left, the squarish box is the battery, right? It's a smaller profile battery. They're very proud about that, and we'll get into that detail. But I guess it's a bit more energy dense. I think what they've kind of done mostly is made it deeper. They've stacked one on top of the other coming out from the wall rather than, so it's thicker than you might think. Then next to it is the combiner box. There is no smart switch. There is no smart switch at all. And then the third piece that they're going to do is, you see in the meter, there's a collar. There's a meter collar that gets put into it. So those are the three major components, which are right here. So we talk about the IQ battery 10C, and that they say with 34% greater energy density. Well, yeah, okay, it is more energy dense. I'm sure they've looked at the chemical architecture of the battery and gone with, a little bit better. These things get improved. But then they claim I think it's like 60 some percent less wall space. Well, that's because they made it thicker. The combiner box, it has a lot of different functions that the old combiner box didn't have. And then you've got the meter collar. And the meter collar also does some things that were in the smart switch. So it's actually, I was pretty impressed when I was starting to look at this system. So I think it's nice. It's certainly an improvement. And I thought their old system was pretty good. But one of my criticisms of the old system, and even this one to a less extent, the Enphase system is a good system, but it just reminds me of back when I was in high school and we were all going out buying really, really tricked out sound systems. And we would buy big speakers and a turntable and a tuner and tape decks, and you had just a whole wall of this equipment, and all of it was very expensive to get just the highest quality tunes. And now everybody's just using an iPhone and earbuds. We got to get to the earbud stage. Yeah, Siggy, you've got a question?
Yeah, the photo you showed, it's not showing a disconnect in front of the gateway or combiner.
Let me see.
There's a couple of issues on the new one.
Yeah.
There, it goes straight from the line side connection into the, I guess, combiner you call it now. And
Yeah.
two concerns I have. Is it service rated, and is there a 200 amp disconnect? And the second one is that a lot of utilities won't go for that.
Yeah, I can see that there has to be an AC disconnect between the combiner and the meter, I would assume.
Yeah.
I guess they just didn't do that because it's not their product. I mean, they should have. They should have. But yeah, most utilities are going to require. And this looks like one of those. I'm assuming their service panel is right there next to the meter. This is one of those outside service panel things. I don't see them here very much in Ohio. Do you have them there in Florida?
Yeah, they're common. Those
Yeah,
meter mains.
it must be a warm weather thing like Florida, California. But
Yeah, on
out
those
here,
you can't do a easy line side tap in there in that thing. So that's why they have the collar.
yeah. So, all right, well, let's jump in. We'll talk about the battery. So the 10C battery. And one of the things I found interesting when I was looking at this, I didn't do a very deep dive on it, but it says here, if you just look at this description, it says all-in-one AC storage system, IQ battery, integrates with 240 volt and 120 volt microinverters. Now, I've never seen a 120 volt microinverter. Is that just me? Maybe that 120 volt is the product I just showed you. I guess that is, the one that plugs into the wall. Um, I don't think they're common. I just don't think. It says capacity of 10 kilowatt hours, delivering 7 kW of continuous power output. So that's the maximum load or the maximum draw it'll deal with. People were criticizing that that's still pretty small compared to competition, but I don't have a sense of that yet. I also wanted to see what these things are selling for. And I did find this, the 10C, selling out there for 7,000 bucks. Have any of you guys installed these? Do you know if that's about right? Pretty much market price, or is this a good sale that I happened to run across? So guess not. Okay, so anyway, that gives you a sense of it. I think we said the other one was 4,000 for the 5, and this is 7,000. Said we've sold a couple and they were less expensive than third. Okay, that's good. Yeah, if you look at the width and the depth here, this spec sheet here on the power rating, it says it's got a DC round trip of 96%, AC round trip of 90%. Remember, these things typically it's an AC coupled system. So you're getting AC power coming from your microinverters. It then has to be converted to DC to go into the battery. And then there are microinverters that are built in, battery-based microinverters in that box that then regenerate that DC power back to AC. So I guess realistically, we're talking about a 10% loss when you get power going in, power coming out. So hopefully that's built into their reference number when they talk about 10 kilowatt hours. But either way, and then you see the depth and the width. So the depth is and this was something that was interesting, and I had to do a little bit of research there. But if you look at the weights, right, it says the total weight is 317 pounds. So one of the issues I was thinking about was, boy, you try and lift that, but then their lifting weight, and it's covered on my screen with my little arrows. But if I remember right, can you guys tell me, just somebody shout out, what is the weight for lifting on the screen there?
126.
126. Okay. Yeah, that makes sense. So then what they were explaining is basically this battery is componentized components. So it's a 10 kW battery, but there are essentially two 5 kW batteries that you put one on top of the other. So when you're installing it, you would put up the mount and then you would put the first panel, the first battery in, then you would connect the second battery to the front of that, and then you would put the cover over it. So you're not just lifting this thing up, you're doing it in two parts. So yeah, it's a 317-pound battery, but they kept being it said it's still a two-person install, because, if you were trying to install a 317-pound battery, you'd need lifts and special equipment to try and do that. So that was one of the things that they were quite proud about there. So they really did introduce this to compete with the Tesla Powerwall 3, which is apparently cleaning their clock a little bit. They've got a 15-year warranty. Yeah, Pete, you had a question? You there, Pete? Oh, Bruce, yeah, you're there you
There
go.
we go. Okay. How does one put 317 pounds of eccentric load on a wall and have the wall not collapse?
Yeah. I know they always do that, right? They just show you mounting it on. I would floor mount that thing. I mean, I'm
Absolutely.
sure there's. I mean, that seems a better option, but who knows? I mean, it feels like if you're putting 300 pounds, especially if it's kind of forward heavy, it's going to want to pull loose. So I would want to put at least something under it to support it, whether it's the floor or you're building up some sort of mount. But you certainly wouldn't want to put a couple of molly bolts into a drywall, and hope that that's going to hold it. So,
Or
Could,
uh,
even two by fours. Even
yeah,
two by fours. They'll just pull out.
yeah, yeah. You're dealing with heavy stuff, so yeah. You raise a
does
good
it
point.
does it make sense to install this inside of the house instead of out on a wall?
Well, now you're talking about, when you get into what is the standard? I mean, basically, the standard wants these things outdoors anyway. Um, so you can do smaller units inside, but the new standard, I'm trying to think, I'm going by memory. I think it's NFPA 655. Maybe Siggy remembers that. But there is new battery locations standard, so you'd want to comply with that. I don't think they want anything more than 20 kilowatt hours inside the home, and it's got to be in a place that's like you couldn't put it in a bedroom or a living area. And mostly they want them outdoors. They still have a fear of battery or fire. Um, this is supposedly a new, safer architecture, less prone to thermal runaway, no cooling fans, so more compact, energy dense, modular in nature. Like I said, if you look at the size, the footprint there on your wall, and all of these, they all talk about mounting them on your wall, but realistically, I mean, first off, are you going to lift a Tesla Powerwall 275 pounds or so up onto the wall? Still got that issue. You've got the profile of it looks smaller. It looks smaller for sure. But these things are still big. Even the smallest one is still pretty big. So, okay, then the combiner box. Well, the combiner box is a big difference. Big difference if you've installed combiner boxes. They've got a lot of stuff in there. And let's see if I can do it justice. Well, first off, one of the big differences is $1,700 versus I know we used to look at it. It was $600 for the combiner box. Then suddenly it was $800. Now it's $1,700. So, but again, you're taking a lot of the switching type things and you're putting it in. Oh, one thing I didn't mention with the battery, and maybe I didn't mention it because I don't 100% understand it, but they were saying that the battery will self-generate a neutral, right? I'm pretty sure that's what that neutral generation that allows you to go with the 120 or the 240 has now been moved into the battery itself and not in the smart switch. So that's something we don't need anymore, and that was a big part of the smart switch. All right, so let's see what's in this combiner box. Well, there's still ports or still breaker locations for 4 20 amp solar PV branch circuits. So that at its core, that's what a combiner box is, right? It's going to combine those branch circuits and then allow you to output, at a higher amperage. There are also 2 80 amp battery circuits. So you could hook in 4 of those 10C units. Now, before you had to hook those into the controller, but now you're hooking them in directly to the combiner box. It also has a connection for their EV charger. So there is a direct connection for the EV charge from there. And it is a controlled charger. It's not just a hookup for a 240 breaker. So there is some control functionality built in. It also has a built-in load controller, where that load controller was an additional part. Now it's built in, but it's looking at shedding loads. Like I said, it's the opposite of enabling certain loads and you would connect to them. It's basically saying up to 80 amps of your load, you could hook these things up and then we could set a priority for which ones do you shed first. So the load controller is built into this combiner box. The CTs are pre-installed. So you don't have to run those CTs to for the battery or for the array. Those are already pre-installed in there, so there's no running that wire. And then when we get to the collar, the CTs are built into the collar. So for the going back and forth from the grid. So there is no installation of CTs with this system, and CTs are current transformers. They're the things that are measuring the amps so that you can measure the flow of electricity through your system. And then there was an interesting thing, and I hope I get this exactly right. I think I understand the concept, but it isolates the distributed energy resources from the loads. So what that's saying, I think I've got this up. Nope, I know I've got a slide that'll talk to it a little bit about that, but it allows you, maybe I'm talking about two different things here. The concept I'm trying to get across, and I hope I'm not mixing this up, is that normally when you would hook in, you would have to worry, since you're hooking in directly to your loads, you would have to worry about the 120% rule. And that 120% rule will not apply with these systems. And I know I've got a slide that talks about that a little bit further. The collar here is a collar that just fits right on your meter box. You just pull off the meter, you stick this collar in there, and then you stick the meter over top of it. And this is where you're making your grid connection. So this is where your CTs are going to be. And it also performs the auto transformer function. It is your disconnect. So when it loses sight of the grid, it disconnects from the grid at that meter collar rather than requiring the smart switch to do it. So now you're isolated 100%. Everything in your home is isolated. So that might be what they meant with that term as I was doing an isolating from the loads. That I'm still questioning. There's also another option here. If the utility will not allow you to mess with their meter, even though you probably had to pay for it, you can put in a separate meter box and just connect that collar down below. So that's a secondary option. One option, of course, just pop the meter off there, stick this collar in, stick your meter back on top. Another one would be to go and tap in and now just put the meter collar there directly below or next to your meter. And yeah, this is where I was saying that when you go and you connect in to your service panel, then the 120% rule does not apply. So there would be no need to upgrade your service. At least that's one of the things they were talking about. And what this is doing is they said that your combiner box is basically smart enough. It's going to monitor how much power is flowing flowing to your loads, and will self-constrict to make sure that you never exceed the 120% of your bus bar. So if you're drawing power from the grid, and you're drawing power from your batteries, and your loads are exceeding, they cannot exceed more than 120% of your bus bar rating when you're feeding into the service panel, which is sort of per normal when you're installing one of these systems. Well, they're basically saying, okay, instead of restricting that through a breaker, and just sort of physically say we're disallowing it to exceed. This system has built-in electronics to monitor that and will not exceed it. So you do not have to worry about the breaker limitation. In fact, you could put in a 100-amp breaker all the way from your combiner box in your service panel. So you could, in theory, have a 200-amp breaker coming from the grid and a 100-amp breaker coming from your array on a 200-amp service panel. And the system is smart enough to know you're never going to exceed 200 amps on that bus bar. So it's going to monitor that, and it will never exceed the 200 amps. That's what they say. So hopefully that makes sense. But it basically, the 120% rule doesn't apply. And their spokes guy was saying, yes, the authorities having jurisdiction are perfectly fine with this and know that it's good. So then also you've got the Enphase EV charger. And originally, I think they just simply did a deal where they branded Clipper Creek chargers, and put their own Enphase logo on it. There was a lot of talk about, there's always been talk about bidirectional charging, EV charging. When can we begin using the EV as our battery backup on our load? Well, we're not there. This is not that. This is connecting up your EV charging, and then you can program it so that you're using your EV as a load dump, for example. So let's say you're in an environment where you've got really crappy net metering rules, and they are going to pay you 4 cents and they're going to charge you 35 cents for electricity or whatever. So you don't want to net meter back to them if you can avoid it, because you're getting paid pennies. So just charge only when you have excess electricity. So use your EV as a load dump. So that's one option. Then, of course, obviously the downside of that is, what if you don't have excess electricity? Will your car ever get charged? So you can program around that as well. It does have Storm Guard. They said that's one of those things where if you get a storm alert, it automatically fully charges your EV from the grid even, just to make sure you got a full charge, because they say we don't want you to be stranded when there's a storm. I'm sure there's a bunch of other kinds of ways that you could use your battery, use the charging, directing power there, direct it there only when, if you've got time of day pricing, things of that nature. So a lot of programmability within this system, but the EV is a connected piece of equipment now, connected in the combiner box, but it is not bidirectional. The spokesperson from Enphase said 2026 bidirectional. Well, they've been saying that. So who knows? The issue here is not the technology. The issue here has to do with standards, how we're going to charge, what vehicles are going to adhere to which standards. So we really need to get buy-in by the automotive industry. That's really what everybody's waiting on. We're getting closer, but they're claiming they're looking at 2026 for full bidirectional. We'll see. And then the other thing that they were making noise about was the IQ9, the next inverter family. And they were kind of hinting around the edges, but it was interesting because it sounds like they're looking at that the next microinverters have to deal with different chemistries and different functionalities of panels. So they're talking about perovskite, tandem panels, things like that. So these things are going to have to be specific to different panel types. So that's one thing. But then they're also talking about distributed generation is what I put down here. But we're really talking about virtual power plants. If you can make money selling your power back to the utility, Now we begin to, how do you get the functionality there of building in, and it sounds like it's more of a software thing, of determining when, making your solar panel an arbitrage kind of situation where you can make money generating during energy emergencies or during peak load demand times. We can, and how can they communicate with each other to set up the Enphase virtual power plant, which is, my guess is what they're moving towards. How can they control that arbitrage, and pool together large groups of these microinverters to be a distributed generator? So that's interesting, moving in that direction. And I don't know when that's going to come about. They didn't say, but we'll see. So
No issue with bifacial panels. That's
I don't think so.
okay.
I don't think that's an issue. It's just how many watts are coming out of it. It's still a silicon-based thing. So yeah, I don't think that, or split cell panels, I don't think cause them any problems. Those are just configurations of, that's kind of how you're slicing the same kind of thing. But my guess is on the horizon, there's going to be, especially perovskite seems to be one that's a different architecture altogether. It's a thin film technology. So that may cause some issues. In the old days, I think it was what, the IQ7s maybe was the split where some of them would work with 60 cell panels and some would work with 72 cell panels. It's like if you go back in time on some of these panels, they wouldn't work with the 72s. So maybe it's something about these other architectures where the current group of microinverters would have a problem, and we just aren't aware of it because it's just not, those technologies are not either available or widely being used. So anybody else have any questions? I've come to the end of my spiel on the float solar. Will it position, how smart are these configurations? I don't know. Are you talking about photovoltaics and whether that's a wind and a hail thing? Not exactly sure.
Yes, yes, I'm seeing now that the risk evaluators for insuring systems are requiring not just positioning for wind, which really only a few rows need to do because they have sort of a deflection capability that's been discovered. It rolls the wind a bit, like trees roll the wind. Okay, and then with the hail, that's becoming a big deal.
Yeah.
So there, you want to go vertical, but you have a counterpart for wind.
Yeah, well, the with the hail, of course, the hail is the number one cause of insurance claims with solar. Now here we're talking more about utility scale, where it really gets into the millions and millions of dollars versus. And my understanding is, of course, there's hail ratings for panels, but you get hit with a softball-sized piece of hail. I don't care what you've rated for it; it's going to get hurt. But what they've been doing is on the tracking systems, turning them vertical. So
Yeah.
turning them vertical in anticipation of a hailstorm. So they've been focusing on some of the predictive nature of hailstorms
Yes.
and the ability to position these panels in a way to avoid as much damage as possible. In a residential install, I don't know that
No,
that's,
you're never gonna, yeah.
yeah,
I mean, I like the old tilted up for winter where we are.
yeah,
And then, for summer, I mean, and then, yes, for winter. So you get the most of the winter sun. I like the simple manual tilt, but this is far more complicated. It involves
yeah,
30-minute reckoning with the weather and storms coming in. But I'm
yeah.
thinking that how many megawatts are going to be on this reservoir?
Oh, on that reservoir, the one in Ohio in the news, I think it was six megawatt photovoltaic system. So 30 acres of
Yeah,
I assume
that's
lakes.
about right. I mean, we're getting to the point where 4.5 megawatts an acre is a very tight, but the thing about it being there, I was trying to figure out whether or not it would be, I think even 6 megawatts might run into a problem if you have hail.
Oh yeah, yeah, yeah. Well, for sure. And I assume with a lake or photovoltaic, I don't think they're putting tracking systems on those photovoltaics. So I
Really?
think you'd be too bad, so sad, you know.
Okay.
My guess is, this one's being put in northern Ohio, and it's not like it's the Texas Panhandle where you're getting those kind of severe hail events. We do here in Ohio get them, occasionally, but um, my guess is it's just one of those risks, they're going to take.
Yeah. And maybe it'll be latitude sensitive. You're up here, you're not down there. I don't know why they get such gigantic hail down there and we don't experience it up here. We get dime size at the worst.
Hey, everything's bigger in Texas, right?
Uh-huh.
There you go.
Cats, you name it.
Uh-huh.
Okay.
All right, Al, you've got a question? You're on mute, Al, there.
Yeah, I live in Northeast Ohio. So where's this photovoltaic reservoir going to be?
It's in Monroeville, and it looks like it's sort of centered between Toledo
Okay.
and Cleveland.
Okay.
Just about dead center and a little bit south of the lake there.
Has it been
Um,
permitted?
oh yeah, it's underway. It's
Oh,
going.
okay.
Yeah. Yeah.
Then the other question I um, had to do with my understanding is there are newer panels coming. Of course, there are newer panels coming out all the time, but there are newer panels available now that have more higher wattage, I guess is the best way to describe it. So you can fit the same number of kilowatts in a smaller space, like on a roof or somewhere. What's the price premium for those things?
Oh, yeah, you're talking about like the 600-watt panels and things like that are
Yes.
that are
Yeah.
out there. I think those are primarily for big commercial and
Okay.
utility scale. Um, I'm sure that the per watt cost is going to be comparable.
Okay.
I would imagine otherwise there'd be no real advantage of doing it. But I
Are
think
they higher wattage just because the panel's bigger, or is it some?
that's part of
Well,
it. Part of it. They're not super efficient things,
okay.
but I mean,
Okay.
these things are getting more efficient, but
Okay.
I think it's just that they're getting bigger and bigger and bigger.
Yeah, and the other advantage to photovoltaics, and they use this widely in countries like India, they cover irrigation canals with panels to reduce the evaporation and the water loss from these irrigation canals, which also cools the back of the panel and makes them more efficient in the really hot climates like we have here in Ohio now.
Yeah. Yeah, I saw a plan that I know there are a lot of irrigation canals in California, and they were talking about how you could just simply straddle them
Okay.
with solar, where they don't even have to be put on the water. They could just
Right.
sort of be across these canals, and you could power great swaths of California just by using that land. So it's land that otherwise is not being used except just to house water.
Right.
And apparently those panels don't do any damage to the wildlife or to the marine. In fact, they say they enhance it. I mean, as a kid or even as an adult, if you go hanging out at the dock, all the fish are underneath the dock. They want to be in the
Yeah.
shade.
Yeah.
So now, obviously, if you covered the entire surface, that might cause an issue. They've got to have sunlight somehow, I sure. But yeah, it's another option. When we talk about vertical panels going on walls, going on fences, we're talking about photovoltaic issues, we're talking about agrivoltaic. It's just that the industry's starting to grow up a little bit, and so we're getting more and more options all the time. There was a question I saw it there. Do you have access to the thing where you're talking about can you get part of the system now? Yeah, when upgrading to 6C, if you don't want the meter collar. I think you got to have the meter collar. I think it's a system. It's everything or nothing. Because you would not have your disconnect if you were upgrading and you wanted to wait to get the collar. I'm pretty sure that's the issue there. Because the question was, if I get a 6C, can I wait and install the meter collar later? And I don't think so, because you're basically, if you're putting in a battery, you've got to have a way of disconnecting from the grid. And, when the grid goes down. And that's where it's being done. That's where it's being done, is in the meter collar. Okay. All right. I think we're at the end of our time. I appreciate your attention, and we'll see you. I don't remember when our next one will be, but I'll let you know. All right. So take care. All right. Bye-bye.
Thanks.
Bye-bye.